So next we'll take a look at the worksheet from section 13.3, and a big concept that we're going to look at obviously is radians, but then how we can convert between radians and degrees. So sometimes we might want our angle measure in radians, sometimes we might want it in degrees. So we'll talk about how you can convert between the two. And where is this one, number one here? All right. So heading back to the unit circle here quick. And let me get to your guys' class. We can use what's called a conversion rate. So a conversion rate is used to convert between different units. 12 inches in a foot, 5,280 feet in a mile, 3 feet in a yard. If you're in chemistry right now, you've talked a lot about converting units, because when you're dealing with elements and moles and reactions, you're constantly converting things to different units. And the process is called, some people call it stoichiometry, some people call it I can't think of the other word right now, but dimension analysis is also what it's called. So it might be called a little bit different things, but all in all, what it happens is it uses multiplication of fractions to convert units using conversion rates. And the conversion rate that we are going to use, so we just got done talking about the unit circle. If you watch that video, the full circle has 2 pi radians, because the circumference of a circle is 2 pi r. Our unit circle has a radius of 1. So it takes 2 pi radians to get all the way around your circle. A nice conversion rate then is that halfway around your circle, pi is identical to 180 degrees. So there's a conversion rate. So pi radians equals 180 degrees. So it's similar to 12 inches equals 1 foot. We can use that conversion to convert between different units. And we're going to use a process called dimension analysis to do this. So heading into our practice problems, we're going to write each measure in radians, and then we're going to express our answer in terms of pi as a decimal, and as a decimal rounded to the nearest hundredth. Now our conversion that we're going to use is that pi is equal to 180 degrees. And that just is based on how our circumference works on our circle. So there's our conversion rate. Now to start out, you can take your degree measure, and we're going to write it as a fraction. So I just said that when you start to use dimension analysis, you're using a multiplication of fractions process. So we're going to take our given amount, 90 degrees, negative 90 degrees, and we're going to rewrite that as a fraction. And what dimension analysis does is it takes and it cancels out the unit that you started with, and it converts it to the unit that you are moving to. So 90 degrees up in my numerator, if I want to cancel out a unit, I'm going to put the unit down in my denominator. So it's very similar to how numbers will cancel out if you have the same number in the numerator denominator, or factors of the same number in the numerator denominator, they will cancel out. Well, units also will cancel out. So I've got my degrees up here, degrees down here. Since there's a degree in the numerator denominator, those will factor out. My chemistry teacher calls it the factor label theorem, because you're factoring out your labels. So the degrees are going to factor just like numbers would in the numerator denominator. Then up here, we're going to have our pi. And then for radians, you can just put RAD. That's the universal symbol for radians. Now we multiply our fractions. So multiplying fractions, you can look for common factors. So first, our labels will factor. So those degrees will cancel. But also 90 and 180 have a 90 in common. So that becomes a 1. This becomes a 2, because 180 divided by 90 is going to be 2. Now we can take our numerator. 1 times 90 is, excuse me, negative 1 times 90 is negative pi. 1 times 2 is going to be 2. So I got negative pi over 2. Now if we just take a quick peek back at the unit circle, negative 90 degrees is going to be heading clockwise. So I'm heading down to here. Okay, so negative 90 degrees. But I can kind of look up here. A 90-degree turn for radians is going to be pi over 2. And that's exactly what I got. I just got negative pi over 2, which means I'm going the clockwise direction. So negative pi over 2 ends up being my amount of radians in this particular problem. So from there, I've got my radians as far as terms of pi. The second thing I want to do is I want to round this to the nearest hundredth in a decimal form. So to do that, we do have to get to our calculator. So we'll open up our calculator and we'll be able to take that and convert that to a decimal value. So we'll hit negative. The pi button is your power button above the divide. Second, hit the power button, divide that by 2, and we're going to get about negative 1.57. So there's our amount of radians as a decimal, negative 1.57. So there would be our two answers. So what we did to convert from degrees to radian, and you'll kind of follow this same model because they're all going to be set up the same. Degree to radian, you are going to multiply by the conversion factor of pi over 180. And that's consistent every time you multiply, or every time you convert from a degree measure to a radian measure, you're going to multiply by the conversion factor of pi over 180. So let's head down to problem 2. So I got 160 degrees. So we'll write that as a fraction, 160 degrees over 1. Times that by pi radians over 180 degrees. And factor label theorem, your labels will factor. 180 and 160 have a 20 in common, so that's going to become 8. 180 becomes a 9. 8 times pi is 8 pi. 1 times 9 is going to be 9. So I'd have 8 pi over 9. Heading to your calculator, you can also use the fraction button, alpha y equals, open up your fraction. We'll put 8 pi up in the numerator, 9 in the denominator. There's going to be our decimal value. So nearest hundredth, 2.79. Perfect. So we don't need to round the 0.79 up at all or down. It's just going to be 2.79 radians. So there's our amount of arc length around the circle for 160 degrees. It's 8 pi over 9 for its arc length. Lastly, 20 degrees, we'll take 20 over 1 equals, times pi over 180. And the degrees again will factor out. 20 and 180 have a 20 in common. That becomes a 1. That's going to become a 9. And pi times 1 is still pi over 9 would be my radians. And we'll head to our calculator again and take pi divided by 9. And that'll be our decimal measure. So 0.349, the 9 makes that 4 round up to a 5, so we get 0.35. And that's the amount of arc length for our unit circle to go 20 degrees. So there's our 3 results when we take degrees, convert it to radians. The amount of arc length to go around your circle is given as these radians. Now we're going to flip the script and go from radians back to degrees. So we can do both of these directions. So we can go from radians to degrees, degrees to radians, either way. So let's open up problem 2. So write each measure in degrees, round your answer to the nearest degree if necessary. So again, we are going to take the radians and rewrite those as fractions. So take 3 pi and put it over 1. And remember, this is 3 pi radians, so I should put the units there. All right, so if we want 3 pi radians to convert that degrees, we're still using that pi is equivalent to 180 degrees. So 180 degrees is half the circle. Pi represents half the circle as far as the arc length. So 3 pi radians over 1. If I have my radians in the numerator, dimension analysis, I want my radians down in the denominator so that they factor out. So pi radians goes down here. And 180 degrees goes up in my numerator. So factor label theorem, your radians are going to factor. We also have a pi in common, so pi here, cancels out. 3 times 180 is 540 degrees. In my denominator, I just have a 1, so final answer is 540 degrees. And we don't need to convert that anything else like we did with the radians above. That's just going to be our final result. A quick look at the unit circle. Since a full circle is 2 pi, because 2 pi times the radius is still 2 pi, that would be equivalent to 360 degrees. So I've just done a full lap. 540 degrees would be another 180, which would bring me to right here. That's also 3 pi because 2 pi is one full lap to get to here, and another pi gets me to here. There's my 3 pi, gets me to that position. So 3 pi, 540 degrees are the same thing. Those would be equivalent. Negative 2 pi over 3 radians. We're going to convert that next. Just really quick, when we go from radians to degrees, we're using the same conversion factor every time. So radians to degree, we now are multiplying so that our degrees are in the numerator. So it's 180 degrees over pi radians every time. So when we convert from radians to degrees, we're going to multiply by this conversion factor. And that'll always get your labels of radians to cancel out and convert you back to degrees. So there's our fraction that we'll use every time we do this. So here we're going to go negative 2 pi over 3 radians. And I just put the negative up in the numerator. It's the same thing as having the negative out in front. So negative 2 pi over 3 times 180 degrees over pi. So your radians will factor out. Also, your pi's are going to factor. Pi factors here, pi factors here. You have a 3 and a 180, so the 3 can become a 1. The 180 can become a 60. Negative 2 times 60 is negative 120. So there would be our degree measure, negative 120 degrees. 2 pi over 3, when we were going through the unit circle, that was one of those stops that we had. 2 pi over 3 is right here. And that is equivalent to 120 degrees. The only thing we did in that problem is we went clockwise. So 120 degrees would bring me to, whoops, right here, negative 120. Negative 2 pi over 3 is equivalent to 4 pi over 3. So there's where we're looking at on that problem. Go plug it in, Mauser. I'll do it after I'm done with this. I'm helping somebody. Next, we have a 1.57 radians, which that looks familiar to me. I think that was from our last problem, number 1. So 1.57 over 1 times 180 degrees over pi. Now, if our radians start out in a just a number answer with not in terms of pi, then our degrees are going to be in terms of pi. So I'm going to take 1.57 times 180. We'll figure that out, and our answer is going to be over pi. So pi will be in our answer because the radian started out not in terms of pi. So we'll head back to our calculator. We'll take 1.57 times 180, and we get 282.6. So we're going to get 282.6 degrees over pi. So there's going to be our degree measure. Not the prettiest degree measure, but that would be our situation. Now, 1.57 we did above there, that was that pi over 4. So really this is going to be about 45 degrees is what this one would actually be. But since 1.57 was there, that's what we're going to use. So that would be our final answer. So there's just a quick way to convert, and it's also very helpful if you are looking at taking chemistry next year, or you're looking at a career in chemistry or any type of science. It is the method that's used to convert units all the time. So it's a good way to start practicing getting prepared for science backgrounds. All right, so there's problems 1 and 2. And just remember, if you're watching this, you can always rewind and rewatch those problems if you need to. All right, so we'll open up then our third problem. Sorry. Looking at which quadrant the terminal side of each angle lies. And for pi over 3, we'll use our unit circle for that. We can head into here. 4 pi over 3, that's positive, so I am going counterclockwise. So I'm going around this way. Heading to here, 4 pi over 3 is going to be right here. And in our coordinate plane, quadrant 1 is right here. Quadrant 2 is right here. 4 pi over 3 then is in quadrant 3, which is right there. So heading back to that problem, simple answer is which quadrant it's in. It's in quadrant 3. Done with that one. We head into the next one, 6 pi over 5. If you look at your unit circle, there is no 6 pi over 5 anywhere. So 6 pi over 5, where is it? Well, this is 6 pi over 4, which if you think about fractions, 6 pi over 4 is going to be bigger than 6 pi over 5, because 4, when you split like a pizza or something into 4 pieces, the pieces are going to be bigger than if you split it into 5 pieces. So that is going to be a little bit bigger. But maybe it might be helpful for this one to convert it to degrees, because then we can kind of tell where the degree measure is. Might be a little easier for us to see that. So we'll take 6 pi over 5 and we'll convert that to degrees. We just did that, so it's not a very hard thing to do. Since we're trying to cancel out radians, we're going to put the radian unit in the denominator and multiply our fractions. So pi's are going to cancel. 180 and 5 do have a 5 in common, so that becomes 1. 180 divided by 5 becomes 36. So 6 times 36, that's going to give me 216 degrees. Now that might be a little bit more familiar to us. So 216 degrees, if we go to our unit circle, this is 180, this is 270, 216 is going to be in between those two, which means I have to be, for this one, in the third quadrant. So that one also is going to be in the third quadrant. So you have the luxury now, if you're looking at radians, you can convert them back to degrees. Might be a little bit more familiar for us. So there would be problem 3. Heading to problem 4. So the measure of an angle in standard position is given. Find the exact values of sine and cosine for each angle measure. So you can also read sine and cosine based on your radian measures. So what we did in section 13.2 is when we were given an angle, you can go to your unit circle, you can find that angle measure, and then you've got your cosine and sine as the x and y values. Now we're just looking at the radians. So radians are pi over 6. We'll head to our unit circle. Here's pi over 6. There's your cosine, and there's your sine. Pi over 6, 30 degrees are the exact same thing. We're just looking at the angle measure a little differently. We're just talking about this arc length. So of this whole circle, this represents pi over 6 of that arc length, and there's your two measures. So we'll fill that in. Sine value at that position was 1/2. And cosine value, square root of 3. It's a little bit harder to do this when I'm zoomed out so far. The square root of 3 over 2. Done. So there they are. So find the exact, if it said round to the nearest decimal, we would just convert these to decimals. So hopefully you're starting to memorize their decimal values as well. That would be 0.5, obviously, and then this one was 0.87. So if it said that, it doesn't, but it doesn't hurt. There it is. There's our two decimal values. Next, we got negative pi over 4. Pay attention, the negative does mean you're going in a clockwise direction. So heading to our unit circle, pi over 4 is right here if we're going counterclockwise. That's 45 degrees counterclockwise. That means we're going 45 degrees clockwise. That would be this position. So negative pi over 4 is the exact same as 7 pi over 4. They are coterminal. So there's your cosine, square root of 2 over 2, sine, negative square root of 2 over 2. So there's your sine, negative square root of 2 over 2, and your cosine, square root of 2 over 2. So hopefully you're starting to find some tips and tricks on finding those cosine and sine values. A lot of the videos I watched that you guys posted had, all of them are over 2, and then you can just count the x's go 1, 2, 3, the y's go 1, 2, 3 up, and then you can square root everything. Square root of 1 is still 1. So kind of some tips and tricks to find those sine and cosines. So by the end of chapter 13, you should be able to fill in your whole unit circle on your own. So that would be a goal to have. Next, 2 pi over 3, and that's going to be a positive 2 pi over 3, which means we're going counterclockwise. 2 pi over 3, boom, there it is, right here. So we look at, there's your cosine, there's your sine, and it's one of those 30, 60, 90s, so it's square root of 3 over 2. And cosine is negative 1/2. And similar to what we did in 13.2, we just now are using the radians as our angle measure and finding those. Heading into then number 5 next, we're going to use radians to find arc lengths on circles. So get this one saved. And open up number 5. So number 5, we're going to look at finding the arc lengths of some circles. So this might relate to like gears that are circular or bike wheels, and we're trying to find out just partial lengths around the circle. So the quality isn't that great, but we're looking for this orange arc length that's going on right here. So we're trying to find out what is that length. And all we're given is we're given the radian measure. So we're given the section of the circle that represents that particular arc length. So looking at this first problem, it says that we are moving amount of radians is pi over 3. So we're talking about this section right here represents pi over 3 out of the full 2 pi going around the circle. And then our radius is 3. Now, when we were doing all our radians with our unit circle, our radians was always 1. So 2 pi would be our full circumference. Well, now our radius is 3, but we still know the amount of radians is pi over 3. So we still know that of that 2 pi that goes all the way around the circle, that this is talking about pi over 3. of that full lap. To find this arc length then, I'm going to try to highlight it in red a little better. We know that this represents the radians, pi over 3. We can multiply that by the radius to figure out what this length is. So now instead of it being a unit circle, which has a radius of 1, now it has a radius of 3. So we can just take that pi over 3, times it by 3 to represent what that full length is. And there's a formula for that. It's called S equals R theta. And theta has to be in radians. It doesn't work for degrees because the theta has to represent the fraction of that 2 pi. And here we're representing pi over 3 of that 2 pi. So to find S is your arc length. S is going to equal my radius, which is 3, times my radians, which is pi over 3. 3 times pi is 3 pi. And 3 wasn't as a fraction, but there would be a 1 below this 3. So 1 times 3 is 3. So I get 3 pi over 3, which the 3's cancel out. So the length of that particular arc is going to be pi. So there's my length from this position right here and this position right here. And that makes sense because this whole circle, since it has a radius of 3, is going to be 6 pi. 2 pi times 3 is going to be 6 pi. That's something you studied in geometry and then before that in pre-algebra. So 2 pi times 3 is 6 pi. And then this pi over 3 represents 1/6 of that circle. So 1/6 of the circle would be pi. So this length of t right here is going to be pi units because the whole circle was 6 pi. So that section is going to be just simply pi. It does say we're going to round our answer to the nearest tenth. So pi is 3.14. So that would be then just 3.1. So there would be our decimal answer, 3.1. Next, we have 2 pi over 3 with a radius of 5. So we're going to use that same formula. We're going to find, I'll just put, they use the variable c, so we'll put c in. So c is going to equal my radians times my radius. My radius is 5 times 2 pi over 3. There's my radians. No simplifying, 5 and 3 have nothing in common, so this is going to be 10 pi over 3. 10 pi over 3, we're gonna change that to a decimal, so head to our calculator. 10 pi, you can make it a fraction too if you want. 10 pi divided by 3, we get about 10.47, which is going to round to 10.5. So our C as a decimal round to the nearest tenth is going to be 10.5. So that would represent 10.5 units to get from this position right here around my circle over to this position. It takes 10.5 units, or meters in this case. And lastly, we're trying to find W. So W is going to equal my radius, which is 2, times my radians, which is 3 pi over 4. And I'm liking this because the 2 and the 4 are going to have a 2 in common. So that's going to become a 2. That's going to become a 1. So 1 times 3 pi is just going to be 3 pi. And over 2. And we'll convert that to a decimal, 3 pi over 2. 3 pi divided by 2, and we get 4.7. So our final result would be 4.7. And that would be meters. I forgot to put the units, but we're just representing that length around our circle. So simple formula that we can use is this right here. Your arc length is always going to equal your radius of your circle times the radians, and making sure that your radians is in degrees. So maybe you're wondering, well, if it gives me in degrees, can I still do the problem? Can I still find the arc length? Yes, you can, because you can convert your degrees back to radians. And then once you're back to radians, you are set to go. So there's how we can find arc lengths using radians. So radians are very handy, very nice to know what fraction of the circle we are talking about. Always considering that a full circle is 2 pi. All the way around the circle represents 2 pi times that radius. And these radians are just fractions of that 2 pi. All right, we'll open up our last problem, number 6. Draw an angle in standard position with each given measure and then find the values of the cosine and sine of your angle. So we'll do this with the unit circle again. So first, we're going to estimate about where the angle is, doing our best. So no judgment here if your angles are a little off, but if we're going to 7 pi over 4, remember this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, we're counting by our 45s, 5 pi over 4, 6 pi over 4, 7 pi over 4 is going to be roughly right here. And we draw our angle, head not that direction. So roughly that would be our angle. Draw a little arrow at the end. There it is. The sine at that position, the y coordinate is going to be negative, and then all the 45s are the same. It's that square root of 2 over 2, so that's going to be negative square root of 2 over 2. Cosine is positive in the fourth quadrant, so that's square root of 2 over 2. So I'm just thinking about my x and my y coordinate. Cosine is your x. Next is negative 2 pi over 3. So remember that we're dealing with the over 3s now. That's going to be your 30s, 60s, 90s. So we'll count it out and then we'll go look at it on the unit circle as well. So 30 degrees would be pi over 6. And then the 60 degrees right here would be 2 pi over 6, 3 pi over 6, and then 4 pi over 6 is going to be right here. And 4 pi over 6 simplifies down to 2 pi over 3. 4/6, 2/3, same thing. So there's going to be our angle we're talking about. So we are dealing with the 30, 60, 90s. So looking right here, my y coordinate is going to be that negative square root of 3 over 2. So negative square root of 3 over 2. And cosine is still negative. It's the x-axis. It's going to be negative 1/2. So all those 30, 60, 90 sines and cosines are the same. And I'm just looking at the y would be the longer leg. That's going to be negative square root of 3 over 2. The x coordinate is going to be the shorter leg. So negative 1/2. And finally, we have 5 pi over 2. So 5 pi over 2, think of 5 over 2, that's 2.5. So we're actually going a full circle around. So we're going a full, see if I can draw that. We're going a full 2 pi here, right like that. But then we're going another pi over 2. So we've went a full 2 pi, and then we're adding another pi over 2 to make it 5 pi over 2. So this 2 pi right here would represent 4 pi over 2. But then we're going another pi over 2 yet. So we got to add on another pi over 2, which pi over 2, get familiar with, that's going to be this 90 degrees up here. Pi over 2 would be right there. So there's my angle in standard position. Find my line here. So there's my angle, pi over 2. And sine and cosine at that, I like that because that's just going to be a sine of 1, a cosine of 0. So there's going to be our position. 5 pi over 2 would be a full 2 pi because 4 pi over 2 is 2 pi. And then to make it 5 pi over 2, we're adding on another pi over 2, which is going to bring us to right there. And just to look at our unit circle to see that, there's your pi over 2. That last problem, 2 pi over 3, we went to here. There's 2 pi over 6, 3 pi over 6, there's 4 pi over 6 would be right there, which is equivalent to 4 pi over 3 as we go that negative direction compared to the positive direction. So radians, positive, negatives work the same as the degrees. Tells you which direction to go on your unit circle. So we'll go back, take a look one last time at that problem. Remember, just pause your video if you need to, if it's going too fast. You can always do that, rewind it, and so on and so forth. That was section 13.3. Thanks for joining in. I'm going to stop the recording.